So this will probably be our shortest lecture video ever. All right. So to solve equations with fractions, you're going to use the multiplication property of equality, which just basically says this. Whatever the denominator is, multiply both sides of the equation by it. That's what your answer is. So let me show you what I mean. So here's a problem. F over 4 equals negative 20. Now, before you do anything, we need to take a step back, a 30,000 foot view, and we ask ourselves, what are we doing in this problem? Well, we are solving. Then when you zoom down a little bit, you go, okay, well, what type of numbers am I given? Oh, I have a fraction. Okay, now that I know I have a fraction, I need to multiply both sides of the equation by the denominator. So, Stevie, what is my denominator here in this problem?
4.
4. So here's what I'm going to do. I'm going to multiply both sides of my equation by the number 4. Does that make sense, everyone? Now, there's a reason why we do this. And here's the reason. Everyone just look on the left-hand side of the screen. Don't worry about writing it down. Just watch. On the left-hand side of your screen, this is really 4 over 1. Does everybody agree with that? Now, do you see anything on the left-hand side where you're sitting there and you're going, that is awesome?
The 4.
What about it, Kim?
Do you do this so that you can get the letter alone?
Absolutely. What's going to happen to the 4 in the numerator and the 4 in the denominator?
They reduce.
To what number?
1.
Perfect. And we know 1 times anything is anything. 1 times a number is that number. So on the left-hand side, we're going to get the letter F. And on the right-hand side, what is 4 times negative 20? Well, easy part. A positive times a negative is a negative. That's the easy part. 4 times 20, you got to know how to do that. And that's 80. That's it. That is it. Was it that difficult?
No.
All you got to do is know this right here. I'm going to put a big box around it. If it'll let me, there we go. You just know that property. Okay? Because here's the thing, at the end of the semester, when we get to chapter 8, we're going to be solving linear equations. And what we're going to do is we're going to take every single thing that we learned in chapters 1 through 6 or 1 through 7 and just combine it. And what's beautiful about that is there are 6 steps to solve a linear equation. That's all you need to know. That's what I'm going to be testing you on. 6 steps. Here, in this entire chapter, I'm going to be testing you on 8 things. And you got 8 flashcards. That's what I'm going to be. There's your review right there. All right, let's keep going. Let's do some more examples. Am I moving too fast? Are we okay? All right, here's another one. Okay, let's try this one. So we have negative 21 equals y divided by 7. All right, we know we're solving because there's an equal sign there, so we're solving. Maybe I should have wrote that here. Solve. All right? Does it fit the form that we need that we just learned? Yes or no?
Yes.
Absolutely it does. So I'm going to multiply both sides of my equation by what?
7.
7. So on the left-hand side, I'm going to put a 7 out front. On the right-hand side, I'll put a 7 out front. Now, the whole reason why we are doing this is exactly what Kim said in the previous problem. On the right-hand side of the equation, where the variable is, The 7 out front is really 7 over 1. And we have a numerator that's a 7, and then we have a denominator that's a 7. They will reduce. That is the whole reason why you do this. And you're going to hear me say this a lot. What's left over? Well, when you reduce 7 over 7, you can replace it with the number 1. So on the right-hand side, you're left over with, and if you write 1 times y, that's fine, but you don't have to write the number 1. The whole reason why we do that, multiply both sides by 7, is to get rid of that denominator. We hate it, so we get rid of it. The left-hand side is the hard part. A positive times a negative is a negative. 21 times 7 is 147. Does that make sense, everyone? All right. So now I'm going to give you one to do. Try that one for me. And that's a letter S. That's not a 5. So directions are solve. And please solve that problem for me. Sorry, I was going to get something to drink. What'd you get? Anybody get anything?
S equals 45.
Yeah, I think that looks good. Let's try it. So I'm just going to rewrite the problem. And I know I need to multiply both sides of the equation by that denominator. So the denominator is negative 15. So the left-hand side of my problem is the easy part. Even though it contains the variable and it looks more complex, it's actually the easy part because you literally just reduce the 15s. So you're left over with the letter S. On the right-hand side, a negative times a negative is a positive. 15 times 3 is 45. How are we looking so far, everyone? Okay. All right, now we're gonna step up the difficulty here a little bit. We're gonna step up the difficulty. Now the left-hand side is red. 4 over 5 times n. Okay? All right. Now this problem looks a little bit different from the previous ones. Can anybody tell me why this looks a little bit different?
Because there's a fraction with the number.
Yeah. I think, Kim, what you really wanted to say was we actually have like a number for the numerator. Like in all the other ones, it was either a 1 or like the variable was up there. But now you have 4/5 times letter n. But Kim, let me ask you a question. Do you have a fraction?
Yes.
Are the directions solve?
Yes.
What would be your first step then?
I would multiply both sides by 4/5.
By 4/5?
Just kidding. By 5.
Perfect. Because remember, I'm going to scroll up real fast, everybody. I'm going to scroll up real fast. If you look at this rule, it says multiply both sides by the letter B. It doesn't say A over B. It says the letter B. All right? We mathematicians, we are lazy people, and we're the best people to date because we will tell you exactly what we mean. Sometimes we hurt your feelings. Sometimes we'll make your day. All right? But we say exactly what we mean. There is no ambiguity there. So, Solve 4 over 5 times n equals 20. Well, I'm going to rewrite the problem, and I'm going to do exactly what Kim told me to do, which was multiply both sides by 5. Now, let's see if Kim's really on her game today. She signed in at 7, I think it was like 7:32 today. All right?
Oh, my kids don't sleep.
Yeah. Kim was so excited. You were so excited to be in math class today. So here we go. You ready? The hard part is on the right-hand side of the equation. 5 times 20, you got to know that's 100. Here's the easy part. Kim, why are we multiplying both sides by 5?
Because you want to get the n alone.
Okay, and what's going to happen to the 5 that I'm multiplying by? And I'm going to highlight that for us. So what happens to this 5 that we multiplied by and this 5 in my denominator? What happens to them?
They just reduce.
They reduce. Perfect. So I can scratch them out. Would you agree?
Yes.
So
And
now,
4n
perfect.
100. And
So,
then you're gonna
slow down, slow down, slow down.
But
Hold on. Slow down. Slow down. You're right. You are an avalanche today, and I love it. All right? The whole reason why we multiply both sides by that denominator is to get rid of the denominator. So when we multiply both sides by 5, we can scratch out the denominator. And then I asked the question to Kim, what's left over? And you said 4 times n, correct? Perfect. Now, what do we do next?
divide both sides by 4.
We divide both sides by 4, which is a chapter 3 question. Okay? So we divide both sides by 4. And look on the left-hand side. You have a 4 in a numerator and a 4 in a denominator. What happens to them?
Reduce.
Perfect. So we're left over with n on the left-hand side. And 100 divided by 4 is 25. Does everybody see that?
Yeah.
See, this is we're pulling everything together now that we've learned. Simplifying, n over n equals 1 stuff. I mean, everything's kind of just coming in. It's all fitting into its spot now. All right, how are we looking? I'm going to give you one to do. Take your time. Think your way through it. Try that for me, please. I always forget to write the directions because I'm so excited. Solve. 3 over 10 times p equals 30. Okay, are we good? Are we ready?
Yes.
Who got an answer?
It's 100. P equals 100.
Okay, p equals 100. I think that looks good. Let's go ahead and let's try this now. What I like to do is read the problem over again. 3 over 10 times p equals 30. So on the left-hand side, I notice that's where my fraction is. So I'm going to multiply both sides of my equation by 10. Now, the left-hand side looks more complicated because it has the variable, and that's the side I'm going to work with. Since I multiplied both sides by 10, the whole reason why I did that is so I can reduce the 10s. What's left over? 3 times p. On the right-hand side, it's going to be 10 times 30, which is 300. Now, I take a deep breath, and I read the problem again. 3 times P equals 30. If you listen to what I'm saying, 3 times P, since I got to get the P by itself, and I said 3 times P, I'm going to do the opposite operation, which is division. So I just divide both sides by 3. P equals 100, which is exactly what Lakendra and Ashley in the chat said. So perfect. All right, let's try another one like this. Am I moving too fast? Are we okay?
Okay.
All right. So here's the next one here. Solve. Look, I wrote down directions correctly the first time. I'm going to use the letter X. So we have negative 2 over 9 times X equals 16. I'm going to let you do this one. All right, what do we get?
I got X equals negative 72.
Anybody else get X equals negative 72? Perfect. All right, let's see how this works. So first thing I'm going to do is just rewrite the problem. And I'm going to multiply both sides by that denominator. Now, I'm trying to, I don't want to say trick you, but does anybody notice something that's different with this problem from all the other ones?
Negative.
Yeah, that negative. Now, you could totally do this if you wanted. You can multiply both sides by negative 9. Is that what we did? Or did you just multiply both sides by 9?
9.
Okay, and that's fine too. Watch what happens. Watch what happens. So on the left-hand side, you have negative 9 in the numerator, and then you have negative 9 in the denominator. So they reduce. So you can just cross them out. You're left over with 2x equals, and now negative 9 times 16 is negative 144. Does that make sense, everyone? Now, some of you may have went this route. So I'm going to just do it over here. You just multiply both sides by 9, and you got negative 2x equals positive 144. Here's what I'm saying. It doesn't matter. If you keep the negative or not, it doesn't matter, because at the end of the day, everything's going to work out. That's how math is. So on the left-hand side of your screen, my problem, I divide both sides by 2 to give me x equals negative 72. Now on the right-hand side, you're going to divide both sides by negative 2. Notice you still get x equals what?
Negative 72.
Negative 72. Okay? So remember, and I went over this a while ago, so remember, negative 2 over 7 is the same exact thing as 2 over negative 7, which is the same exact thing as writing the negative right in the middle. It doesn't matter where it goes. All right? You just got to acknowledge that it's there. All right, how are we looking? Good? All right. So